Dear friends, welcome to Infos. Welcome to Oil and Gas training series. Welcome to our 54th video, Heat Exchanger Part 2. In this video, we are discussing about shell and tube heat exchanger, one of the important and most common using heat exchanger. As you know that one, my previous session onwards, we have started heat exchangers. So I kindly request to watch all of my previous video to get an idea on oil and gas operation, instrumentation, basic mechanical informations. So you will be in the track. So this is my 54th video on heat exchanger. It is a part 2. So in this video we are discussing about the most common using shell and tube heat exchanger. What are the different type of shell and tube heat exchanger and application wise different applications and constructional details or design details you can say. So these things we will discuss today. So welcome to this video. So it is a 3D picture is showing here, shell and tube heat exchanger. Let us see how it is working. So shell and tube heat exchanger is a most common type of heat exchanger in industrial application. They contain a large number of tubes. You can see here. I can take my laser pen. Yeah, here you can see this one. They contain a large number of tubes, sometimes several hundred, packed in a shell with their axis parallel to that of the shell. Heat exchanger take place. One fluid flows inside the tubes while the fluid flows outside the tube through the shell. Here, this is the shell portion, and inside the white color is the tubes. And see, tube side inlet is from here. It is passing to one side. It is passing this way and going there. At the same time, shell side is entering from the opposite side, and because of the baffle, it is going like this, like this, like this, like this. It is going and entering here. Okay, and this is the way it is. Shell and tube heat exchangers are further classified according to the number of shell and tubes involved. So many classifications are. This basic classification we have see that one pass, 1 2 pass, 2 2 pass, 2 3 multi pass, etc. Various passes we have seen already. But in this video we have discussing about more about shell and tube heat exchanger. Shell and tube heat exchanger have two components are there. A tube bundle containing tubes in which side tube flow. See, a tube bundle is there. This is the tube bundle. So it is the tube flow is passing through that one. A shell that encases the tube bundle through the which is the shell side flow. This is the shell side and the shell side flow is there. The shell construction is different. Various other subdivision is there. Shell is the support framework of the tube. This is all the support framework of the tube. Bundle and consists of cylindrical casing. See, the cylindrical casing is there. So slightly in different application, the casing shape will different, varying little bit. And flanges are there. Various flanges are there. You can connect the inlet outlet shell and tube flows. Then nozzles are there. These are the nozzles. Then support system will be there. Support system will be there and cover will be there. So these are the shell detail. And this is one of the YouTube type shell and tube heat exchanger. You can see just to have a look that one. One side it is YouTube. The flow is entering and coming to this side and going back to this side. So it is a two pass two flow is there. See, and YouTubes are bundle of tubes are arranged inside the shell in such a way that when you can remove it for cleaning purpose or so. We will study details in our coming slides. Advantage of YouTube type heat exchanger. Straight tube is also there. See the straight tube. Tube bundles are in a straight line tube sheet. So inlet is there and outlet is there. Straight lines are there. And shell side, of course, the other way it is. And straight tube 2 pass is there. Straight tube 2 pass. See, it is tube side is entering and going, coming back and entering like YouTube. straight tube 2 pass. And this is a 3D picture. You can see that one, it is tube side is a 2 pass and shell side is 1 pass. So this is a 3D picture and a good picture. And another one is a double pipe. See, shell and tube itself in, but double pipe, only 2 tubes are there. Tube side is only 1 tube, a bigger tube, and shell side is covering here. See, it's a double pipe, 1 tube coming and going like this one. Shell side is covering here. One fluid is flows inside the inner tube. The second flow in the space between the larger outer tube and smaller inner tube, which contain the first fluid, like this one. See, this is shell side. Advantage is low cost, easy maintenance, easy of adding additional unit you can add here, multi-purpose. This is the advantage of that one. And this is a flow pattern like same like parallel and counter flow. Disadvantage is may not perform the process requirement. Unit is a standard package like the bundle of tubes, it will not perform. Maybe low temperature application you can use that one. Limited selection of metals, limited application, prone to blockage. These are the advantages are there. This is the heat exchanger looking from outside. This will be, size will be vary, but this will be the overall shape. And this is inside the factory. You can see that one, number of tubes are here, arranging in a pattern. That is a pattern, we will discuss that one in coming slide. See the pattern, it is there, tube sheet and the expansion joints are there. We will see what is that one. So now we will discuss about some design details of heat exchangers in shell and tube heat exchanger, various details we will discuss that one. Shell and tube type, tube sheet is fixed, you can see here, tube sheet is fixed. This is a one bundle of tubes and this is one bundle of tubes. That's why it is two fixed tube sheet and locked at both end. See, you have locked at both end and bundle not removable, and tube external can only be cleaned. Tube external can, in between the space, you can clean by chemical acid washing using standard cleaning method. You can use that one. So this is the first type of shell and tube heat exchanger, fixed tube sheet. You can see fixed tube sheet. If you are getting a time mechanical, especially mechanical background viewers have a chance to getting heat exchanger in open position in any workshop, you have to see that one, it is a what type of heat exchanger, what type of shell and tube, and the design and the construction details to getting an idea on that one, it will be good. So fixed tube sheet and partitions are there, and these baffles and other all standard arrangements. So this is shell and tube fixed tube sheet. So this is also same shell and tube fixed tube sheet. What is the tube sheet is fixed between the channel cover flange and the shell flange here. It is fixed here. It is fixed here. See, channel cover and this one fixed here. So cannot thermally expand or contract. This also cannot thermally expand or contract. So that is in coming slides that limitation is overcoming. So see the expansion joint, look at that one, tube sheet is fixed but shell side expansion joint is added. So shell and tube heat exchanger, fixed tube sheet and shell expansion bellows are there. See, shell expansion bellows. Tube sheet cannot move, it's same as a fixed tube sheet, but shell side, the expansion joint, shell expansion joint allows the shell to thermally expand and contract. So it will adjust that thermal expansion and contraction. He will take care, the shell side will take care. So this is the one type. Another type of fixed tube sheet thermally expansion type. So it is coming under shell and tube heat exchanger. Another one is expansion is not expansion joint, it is a expansion bellows. It is connected between the shell side. Tube sheet is here and shell side is a shell expansion is there. Let us see how it is that one. Shell and tube type, fixed tube sheet, same like a fixed tube sheet. shell expansion bellows are there, here it is there, and tube sheet is fixed. Okay, the shell can be expand and contract because of the bellows movement. Here it will move like this one. Another one, again let us see what is the difference between this one. It is another new name, if not fixed tube sheet, it is a new name, floating head. The head will be floating. This is the float. Head will be moved. So it is basically to prevent that thermal expansion, to accommodate with the thermal expansion. For that this method is using, floating head is using. One tube sheet is fixed. One tube sheet is free to thermally expand and contract, and wasted space between, here some wasted space between tubes and shell. Here it is there and here it is there. Wasted space are there here between. So that is a floating head type 1. Another one is a floating type is there. See, you can shell and tube, floating head, and outer diameter of the tube diameter is smaller than the shell inside diameter. Of course, the tube bundle is free to thermally expand. See, through tube bundle is thermally expand, and that is another one, floating head, thermally expansion type. So another one is the split ring. It is coming in another getting floating head, split ring. The split rings are provided for thermal expansion, free to thermally expand and contract. No wasted space between. See, here it is, the difference is from the previous one. No wasted space between shell and tubes. That is another one. Here it is split ring. Another one is giving float system is giving here. Thermal expansion is possible. So mainly two type of this is split ring and split ring, the split ring in half, and float head cover is removed. Float head cover is removed. Then the bundle can be withdrawn from the opposite side. So two bundle can remove easily for maintenance. So mainly two type of heat exchanger you can see that in these slides, fixed tube sheet and a floating head. And in that one, various arrangements are there for thermal expansion, accommodating with the thermal expansion and contraction. This is the wherever the gasket is using in 1, 2, 3, 4 various sites. The gaskets are using in shell and tube heat exchanger, floating head, shell cover, shell to tube sheet. That is the 3 here, shell to tube sheet. Then tube sheet to channel box here, tube to channel box. This is the channel box where the flow is entering and exiting, and channel box cover, that is here. Here the channel box cover, various places the gaskets are using. And another type of O-ring, ring type, this one is connection method, shell and tube, floating head, gland ring type. So tube sheet is floats along the gland ring, which is sealed from both mediums by two dynamic O-ring. Another one is a U-type one. See, it is here, U-type one, shell and tube heat exchanger. U-type, hairpin type, fixed at one end. One end will be fixed and other end will be freely to expand or float, thermal expansion and contraction according to move, expand. One bolted header box and one welded header box, both are there. So this is the previous one is up to, that is design details, construction details, various of fixed tube sheet and fixed type tube sheet type shell and tube and floating head. In that one, subdivisions are already seen. Now the application wise shell and tubes heat exchanger, what are the different application where we are using that one? So process, mechanical, instrumentation. Viewers, if you get a chance to visit your plant, you see that one, what are the different type of application of a shell and tube heat exchanger, and try to understand more on constructional details. So this is a shell and tube heat exchanger. Look at that one. This is the process equipment, and heat exchanger is connected here. So the bottle liquid is entering from here, and vapors are leaving to heat exchanger and entering to the vessel, process vessel in the upper side. So this is a shell and tube heat exchanger, horizontal type. it is a reboiler type. Horizontal type is a reboiler. Boiler means the liquid is bottom liquid is entering at liquid stage and it is expanding, receiving the heat from the steam and converting to vapor phase. So liquid and vapor mixture entering here. That's why it is called a reboiler type. So use to heat the column product. This product we are heating. This is using in absorbers, distillation columns and strippers. We are using this one, this reboiler in the bottom product heating to release the light end to the top. Use the heat column product. So use a thermosiphon method. So this method is using thermosiphon reboilers. So this is one method, one application of horizontal type heat exchanger, shell and tube. It's a shell and tube reboiler. Vertical type also we can use the same way. Vertical type as well. We can use another one. So use medium through shell side and vapor flashes through the tube to the vessel. That is also possible. The flow we can change it to different way and either tube or shell side according to the selection of a fluid. So either shell and tube, that is here, but in this one we are focusing on application wise. So vertical, horizontal type shell and tube heat exchanger using as a reboiler, and vertical type as well you can use. And another one is shell and tube floating head. This is the here. Look at that one, floating head, and outside stuffing box is there. See the stuffing box is outside. Inlet nozzle attached directly to the floating head cover. Inlet nozzle directly to attach the floating head cover. Here it is there. See, floating head cover, and inlet nozzle float through the stuffing box. See the inlet nozzle through the stuffing box. Another one is bellows type. See here, bellows type heat exchanger, shell and tube, floating head, same bellows type. A flexible bellow is connected between floating head cover and shell. That is another method. Shell and tube heat exchanger only. And shell and tube heat exchanger, floating head, condenser. See, vapor is entering from here. Condenser means vapor entering and the condensate is leaving, and the change of phase is there, vapor to liquid. That is shell and tube condenser type. Hot vapor enter the top of the shell. It is condensed by cold water flowing to the tubes, and the water become hot in the this side. That is floating head, removable head is there. Floating head is a shell and tube and using as a condenser. Another one is a kettle type reboiler. See, it is tubes are here and the shape is slightly different. It look like a kettle. So it is a kettle reboiler type, same using as a reboiler for heating purpose for the process fluid. The column bottom product covers the tube and heat transfer fluid in the tube flashes of the vapor. The vapor then heat the column. So this is the shell side fluid is here vaporing back, and always the tube is immersed in the fluid in the shell side fluid. So level is also maintaining in this one. Always this wear and some mechanical method to always covering the level here. The heating fluid is passing through the tube side and immersed in the shell side fluid. So this is also another one. And kettle type reboiler is a application of shell and tube. And U-tube also, shell and tube reboiler type, same, but U-tube type it's a reboiler. And some mechanical details on tube bundle, tube sheet and tube bundle. See, tube bundle. Many tubes are located into two drilled tube sheet, and that is the pitch arrangements, how the tube arrangement is making, design that one. Square pitch and diamond pitch are the usual one which is using. Tube pitch, square, diamond. That is the square and diamond pitch is usually using for better heat transfer. Design engineers knows this, how to arrange square pitch and diamond pitch. And the shell side we have baffles. Segmental baffles change the shell flow from the top to bottom, creating turbulence with the shell medium covering more tube surface area. See, this is the baffles and this is the outside look, segmented baffles. So it will create a more turbulent flow inside the heat exchanger and providing better heat transfer. This is donut baffles, disc and donut baffles. So the constant rerouting of the flow gives excellent turbulence. This one is the providing excellent turbulence. And thanks for watching this video. I hope we have we have gone through construction details and application wise details of shell and tube heat exchanger. There are number of other heat exchangers are available, plate type and this medium it is using. The other types are there for fin fan coolers are there. So we will review it in our coming sessions. Thank you for watching this video. Have a good day.